Comparison between sets. Sets can be compared in two ways. The first is the equality of sets, and the second is the equivalency of sets. Sets are said to be equal if they have the same number of elements and also identical elements, while the equivalency of sets just involves the number or size of a set. So the number of the elements of a set have to be the same for an equivalent set. Remember that we mentioned that in the sets theory, we don't bother much about the way the sets are arranged. So let's take some example to understand these concepts. This example says if A equals 1, 2, 3, 4, and 5, and B equals 2, 4, 3, 1, and 5, then the set of A equals the set of B. Why is that the case? The reason is that you have the same number of elements, right? You have 5 elements in A, so let's write it in this way. N, meaning the number of elements in A equals 5. Likewise, the number of elements in B equals 5. And the elements are identical. So you have 1 in A, you also have 1 in B. You have 2 in A, you have 2 in B, until you reach 5. So this is why we can say that set A equals set B. And as you can see, the arrangement of the set doesn't matter. We don't care about how the elements are arranged, as long as the two criteria are met. The second concept is the equivalency of sets. Set A, we can also say that set A is equivalent to set B. Why is that the case? Because they have the same number of elements. The cardinality is the same, the size is the same. So A is equivalent to B. The symbol for equivalency in mathematics is 3 lines like this. But I have not seen it in the set theory, but this is the general notation or symbol for equivalency. Let's now take a contrasting example. If set A equals 1, 2, 3, 4, and 5, and set C equals 7, 8, 9, 10, and 11, set A is not equal to set B. Why is that the case? Well, the reason is that even though set A has 5 elements and set C also has 5 elements, the elements that are found in A and the elements are found in C are all distinct and they are not identical. So this is why these sets are not equal. So set A is not equal to set B. Whereas we could say that set A is equivalent to set C because there are 5 elements in A and there are 5 elements in C. So these sets are equivalent but not equal. Sets are said to be equivalent when the number of elements in respective sets is the same. So this should be sets. Let's take another example to wrap up this session. So given set F equals 1, 2, 3, and 4, and set G equals -5, -6, -7, and -8, the number of elements in set F equals the number of elements in set G. The number of elements in set F equals 4, and the number of elements in set G equals 4 as well. So this is why set F and set G are equivalent. They are equivalent, but not equal. So they are not equal, but they are equivalent.